Okay, this is a recording for Monday, September 23rd. We're writing homework 5 today, and it's due Wednesday. I might change that due date at the end of the hour. I'll talk about that as we go. Before we left last time, we talked about the substitution method. So if you were here on Friday, I can't remember if you quite had time to write that down or not, but it will be on the YOLA site. I'll just go through it quickly, and if you're writing, you can be doing that right now. And so we solve one equation for one of the variables in terms of the others. Usually, if there's a 1x or a 1y, we want to get that one alone because that'll be the easiest. If we get alone the like 3y, we might end up with fractions, so that's not desirable. Then we substitute that expression into the other equation, so that we end up with one equation with the same variable in it, and then we solve that equation for whichever variable it was. Once we have that, we substitute that answer in to either one of the originals or our one that we had alone from step 1, and find the second solution. So then we have a problem that says use substitution to solve the system of linear equations. Which variable do you want to start by solving for? Y. In the second one? Yes. So it's most desirable to solve the second equation for y. So we'll take 5x minus y equals 14. Go ahead and walk me through that. Tell me what to do to get this alone. Nope. No, that's a different one. Yep. So we're going to get y alone by subtracting 5x on both sides. And then tell me what I get when I do that. This will be and then how are you going to get rid of that? Multiply by -1 on both sides and by -1, and then that'll be y equals -14 plus 5x. And can I write it as 5x minus 14? I think that's maybe a little bit more. Y equals 5x minus 14. Now that I know what y is, I'm going to substitute that in which equation? The other equation. And so I'm going to take this 2x plus 3y equals 9, and I'm going to take this y right here, and I'm going to replace it with all that. And will you read that off for me? Just a second. Yep. The question is, do you always start with the second equation first? And the answer is not necessarily. I want to pick the one that has a 1x or 1y. If I can find one that has only 1x or 1y, that's what I want to get alone. Yeah, that's fine. Leave them all there. Sure. And so go ahead and substitute that in for me. Okay, and then keep going. Okay, slow down. Oh, because I added 47. You're right, but I had written it bad. And so x equals 3. Now that we have x equals 3, what are we going to do to get y? Yes, and where would you like to put it in? Because I can put it in here or there or there. Where's the easiest? This one. So then we'll take this and go ahead and tell me what the calculation is going to be. I'll go 5 times 3 minus 14, and then y is what? y is 1. To check this, and we'll just check this kind of, we're getting 3, 1 as our answer. So 2 times 3 is 6. 3 times 1 is 3. 6 and 3 is 9. 5 times 3 is 15. Minus 1 is 14. So we can check that as well. And that's the substitution method. I would say, yep. A check mark. This was, the question is, what was this? And it's just a check mark, just notifying myself that I checked it as I went. Now, this is probably my personal least used one. Just kidding. Maybe graphing is my least used one. I don't use this one very much unless I have a variable that has a 1. And otherwise, I'm just going to not use this one. There are times when this one's awesome. Have you ever had two equations where they both start with like y? Like y equals 3x plus 4, y equals 7x minus 2. Well, then the y's are already alone, and you can just put the two x things next to each other and or set equal to each other. The next method is the elimination method. This is my go-to method all the time. If I have to solve a system of equations, I'm generally using the elimination method. So step 1 is to multiply one or both equations by a number to get opposite terms. So one's going to have, 5x, one's going to have negative 5x. And then we add the two equations. That will eliminate one variable and solve for that variable. And then substituting back in to one of the original equations to get the second variable to solve for. Okay, so now we're going to, okay, it's just step 3. I'll leave it like that. Now, in this next one, we're going to use elimination, and you'll notice we have decimals here. So a couple things you can do. You can multiply by something that'll get rid of the decimals. You can move all the decimal places one to the left to kind of see what that gives you. Does anybody have a preference? Do you want to multiply by 10, and then that just makes these bigger numbers? Yes or no? Pardon? 50 for what? Oh. Well, I think if we multiply by 10, it'll be awesome. So here's the equation. 1.5x plus 2y equals 20. 2.5x minus 5 equals negative 25. Say that again. Multiply both of them by 2. If I multiply that one by 5, it won't get rid of the decimal, will it? No. Oh, yeah. Just ignore the decimals and just use them as is. Do you want to do that? I don't know. Oh, I'm sorry. Sorry. There we go. So we'll hash this out if we're done. Yeah. Okay, so if it says that in the homework, I'd like you to practice it that way. But on tests and quizzes, just like that last quiz where I said use, if I specifically, yes, if it says solve by graphing right now, I want you to graph it. Yep. Because, yeah, I do. I just do. Okay, so our choices here, Well, we'll just kind of decide. Our choices are to multiply everything by 10 to get rid of the decimals, or ignore the decimals and just do them as we can. Multiply this one by 5 and that one by 2 because the y's are opposite signs and drop out. Or we could multiply them each by 2 and that would make those drop out. Get rid of the decimals. Okay, so it just makes the numbers bigger. But if we multiply both of them by 10, that will get rid of all of our decimals. And so we'll get 15x plus 20y equals 200. Yeah. Oh, okay. I would maybe just leave space for it then. And then start right here, or I don't know, whatever you want. Okay. So then this one will be 25x minus 50y equals negative 250. And then my numbers, oh, I don't know why I wrote that line under there, but my numbers will be, now before I subtract them, because I need something to drop out, I can, that's okay, we're not backing up now. So can we multiply this by 5 and 2? What did Colin say? I know, yeah. I know, yeah. There's a lot, yeah. So let's do this. I need a multiplier, Grace. Okay, me too. 15 times 5. Oh. $75x. Yeah. For these, we want the actual answer. For those, we would say it was no real solution. So you do it the other way. Okay, multiply by 2. Oh, yeah. Oh, to make these drop out, because they're opposite signs. So if I multiply that by 5, it'll be 100. When I multiply that by 2, it'll be negative 100. Yeah, yeah. And there, go ahead and multiply that for us 2 times. Shh. Okay, now we'll add those. Griffin, go ahead and tell me what we get. And what are we going to do next, Colin? And what do we get? So again, you can decide. We kind of discuss lots of different options. As long as you're going to multiply it by something that's going to make a variable drop out, it doesn't matter whether you make x or y drop out, as long as you make something drop out. So then we have to back substitute. Now, these are not as super desirable, so you can substitute it in this one, this one, this one, or this one. Which one do you want to use? Let's see, Katie. We know x is 4, the 1.5, so go ahead and tell me what we're going to do. And then help me work through that. Mm-hmm. And so for this one, we get a solution of 4, 7. And just kind of thinking about that, 4 times 1.5 is 6, plus 2 times 7 is 14, so that's 20. 2.5 times 4 is 10 minus 35. 10 minus 35 is negative 25. So that one works as well as we go through. So elimination is kind of our go-to method. Now we want to talk about what happens when our variables drop out and we get things that are maybe inconsistent or see what happens. And or three variables. I forgot about the three variables. So yeah, three variables isn't mathematically harder. It's just a little bit different as we go. So you know how to get rid of one variable, correct? By elimination. So look at those three equations. As a matter of fact, look at the first two equations. If you look at those, do you agree if I just add those first two equations, the z's would drop out, correct? And so if I wanted to make these z's drop out, then, so I'm going to group these two together and I'm going to make the z's drop out. Then after that, since I've got z's to drop out, I'm committed to getting z's to drop out. You with me? So then I can either use the first one and the third one and get the z's to drop out, or I can use the second one and the third one to get the z's drop out. It doesn't matter as long as I use two different pairs, you know, of equations. So, you know, obviously I'm not going to do these together. So I'm going to take the first two equations and I'm going to get the z's to drop out of those two. So it's just a repetitive process. So I'm going to take x minus 2y plus z equals 15, 2x plus 3y minus z equals 7. And just a note to self, do you agree I could have gotten the y's to drop out or the x's to drop out, right? And once I commit to one variable, I want that to drop out in all the equations. So just add these two equations together for us, Derek. A equals what? 22. So we got those two variables to drop out. Now, Jason, I want this 5z to drop out. I don't care. Do you want to use the first one and the third one or the second one and the third one? I don't care. First one. So Jason's going to use these two. That first equation, what are you going to multiply by? Just 5. Multiply by 5. So go ahead and we're going to multiply the first equation by 5, and we're going to add it to the third equation. Go ahead. And then go ahead and do that for me. Now, this actually worked out better than we could have imagined because we can just solve for x, correct? So I'm just going to pretend for a minute. I'll write in yellow. Suppose that had been like, you know, plus 3y. We'll just pretend for a moment. Then do you look at these two and do you agree that's just like the last problem, right? Where we have two equations and two unknowns. We could go through that process again. But in this one, it just turns out to be a little easier. Yep. Because I remember right here z dropped out, correct? So I'm committed to making z drop out. So if this is 1z and that's negative 5z, I choose positive 5 to multiply that one by, so that'll be positive 5z and that'll be my negative 5z. So that's how I pick what I want to drop out. So like, let's say there was 5x plus 3y equals 7 and 4x minus 2y equals 3. If I wanted these y's to drop out, I would multiply that one by 2, right? and I would multiply that one by 3, right? And then actually I'm going to make this 20. So if I wanted this to drop out, I could multiply that just by -4, that whole row, and then it would just, this one would stay the same. Does that, are you getting that, what I'm going to do to make something drop out? Other questions? So I'm now taking the first equation and the third equation, and I'll write them here. X minus 2y plus z equals 15, oops, and 4x plus 10y minus 5z equals -3. So when I look at this, like I said a minute ago, I committed to making z drop out, correct? Because I dropped z out here. Yes, once I make one variable drop out, that's the variable I want to drop out all the time, because that'll give me 2 equations. Oh, because all I've got is the z to drop out. That's all I cared about right at that moment. Because if you, okay, so now you know why I use the 5, right? Yes, so we multiply by 5, so that's going to be 5z and -5z, and that drops out. Well, secondarily, what happened, or the extra thing we got, is that the y also dropped out, which will not always be the case. Do you agree? So this could have been 3x plus y equals 22, and 9x plus something y equals a number. And then it would be 2 equations and 2 unknowns, and we'd have to solve for it. It would ordinarily be that way. Right, so I think yeah, plus something, right. So it's the same process, it's like doing it double time. And in this particular case, it worked out to be a little bit easier because the y also dropped out, the z and the y dropped out. So now, because the z and the y dropped out, how can I figure out what x is? And what is x? Okay, now, where can I put that 8 to figure out something else? Derek? Okay, so now I'm going to use this, and I'm going to say, go ahead and put that in for me. Okay, help me solve that. Well, we're doing all 3, but kind of one at a time. Right, exactly. Right. Right. Because that's all we know how to do, is eliminate a variable from 2 equations. So it's the same process, but we have to go through it more than once as we go through. Now, I have another question, because I know x is 8 and y is -2. How am I going to figure out what z is? Into one of the first equations. Okay, so go ahead and put x into the first equation for me. Why don't you go ahead and do that? Here, let me, okay. Oh, 8, just a second, let me catch up. 2 times -2, let's just do it that way. So instead of getting an ordered pair, we get an ordered triple, 8, -2, and 3, x, y, and z. Generally alphabetical order. Yeah, generally. I mean, it's not always. Yeah, but generally, yeah. if it's, that's why I also put that it's X, Y, and Z. Yes, ma'am. This was just me showing how to get that, because a couple people had asked. Because I just used these two, and we just went from these two to there, but then somebody had asked again, so I just rewrote it, is all. Okay, 3 equations and 3 unknowns. So listen carefully. So if you weren't here to do the original elimination, you want to kind of brush up on that, and it'll be on the YOLA site, and these notes will be there. But we can use elimination to get rid of any one variable. So really, I could have not picked the z's to get rid of. Look, I could have used these two. Listen carefully as I say all this. So I could have used these two, multiplied by that by -2. Okay, I need your attention. So put the protractors down. Yeah, wow, I didn't think I'd need to say that. But I could multiply this one by -2, and then add these two together, and the x's would drop out, correct? And I'd have y and z, and I'd have an equation left with y and z in it. Then I could take like these two, if I wanted, and multiply this one by -2 and this one by 1, and add these together, and these x's would drop out, and I'd have y's and z's. Then I would have 2 equations and 2 unknowns, and I would solve it just like this problem that we did with 2 equations and 2 unknowns, and then I'd work my way down. So it's that same thing. I think if you missed some of that, you'll be able to figure that out as we go. These are words that we've had before, so now we want to just make sure that we know what happens. So if we have 2 equations, 2 unknowns, just x and y, here's the 3 things that can happen. Generally, if they're consistent, and I'll write that here, consistent and independent, that's what I'm going to say our first 2 problems were. There is a single answer and there's a single point of intersection. So consistent means you can get it, an answer, and independent means that there's one answer, one point that those 2 lines have in common. So one answer. So the first 2 problems that we did were consistent and independent. Then the other things that can happen, and we have examples of this, the other things that can happen is it can be consistent and dependent, and what happens then is both variables drop out. And so just look at this a minute. Imagine if I wanted to get the x's to drop out. Do you agree I could multiply this by -3 and this by 2, right? You don't have to do it, but just watch. If I do that, I get -6y, y, and the y's and x's are opposite order, that's okay, minus 12x equals -42. And down here, when I multiply this by 2, I get, I'm sorry, that was -6y. I get 6y plus 12x plus equals 42. Do you notice that these are exact opposites of each other? And so, as a matter of fact, what that really means is they are the exact same line, right? They are the exact same line. If I put this in y equals mx plus b form and this in y equals mx plus b form, they would be the exact same equation. They would be the exact same equation. So do they have a solution? Absolutely. Every point is on that line is a solution. So this is consistent and dependent. Dependent means that I put too many dents in there. Dependent means they depend on each other. They are the same line. And so there's an infinite number of solutions. And as a matter of fact, did you listen to me say you can put that in y equals mx plus b form? If I put it in y equals mx plus b form, that tells me what all the answers are, is whatever will solve that equation. And then, you know, when these dropped out, this is 0, 0 equals 0, correct? If these had not been exact opposites and everything else subtracted out, but I got a number here, like maybe I would get 0 on the left and 4 on the right, so I would have 0 equals 4. Is 0 equal to 4? No. And so that would mean that they're inconsistent. They have the same slope, but they don't intersect ever. So inconsistent, and that means they are parallel lines, And I'm sorry, I didn't write that this means they are the same line. And kind of think about subtracting these two equations. They kind of wrote it in this way, and they showed the y equals mx plus b. So y equals negative 2x plus 7, y equals negative 2x plus 7. Those are the exact same line. And so they have the same slope, same y-intercept, the graphs are the same. They have an infinite number of solutions. Say it again. From here, that one. And then over here, if you think about subtracting these two equations or multiplying by -1 here, you'd get 0 there and you'd get some number here, 0 equal to a number, and that's not the same. These have the same slope, different y-intercepts, the lines are parallel, and there's no solution. So, consistent, okay, here's what you need to know. Think about the words consistent and inconsistent. Consistent, yeah, they're kind of opposites, and consistent means there is an answer. Inconsistent means there's no answer, okay? So inconsistent, no answer. And then dependent and independent, if they're independent, they're really two different things, but they have a point of intersection. If they're dependent, they're the exact same thing, just one over the other. They depend on each other. You know, you really just have one equation as you're looking at that. So those are things you need to know as well. And what happens when we use elimination, we end up with that variable dropping out as we go. Dependent. So when you give an answer, that's a good question. The answer for the dependent ones, like for this, you get it in y equals mx plus b form, right? And you see they're exactly the same, correct? And so the way we can give that answer is as a set notation, and usually set builder notation. Remember what that is? So the set of all x such that x, or excuse me, the set of all y, set of all y, such that y equals negative 2x plus 7. And x is an element of the real numbers. So we give it just as that y equals mx plus b kind of answer there as we look at that. And this is just no solution. Either the empty set like this, the empty set like that, you're all familiar with that as well. And this one is an ordered pair. I don't know, it's an XY ordered pair. I don't know what it is there. It's a bad coordinates to just look at. So now my question is, do you need to do one or two like this, that where the variables are going to drop out? Huh? Yes? Do you need to do two of them or just one of them? Which kind do you want to do? I'll surprise myself too because I don't know which one is which. But well, maybe we will do both of them because look at that first one. That's going to be pretty easy, right? Because those, so write down that first one. And do we all agree that we can just add those two equations? And everything we need to have happen will. So if I add these, I get 0x and 0y, right? So on this side, I get 0 equals, what do I get over there? 38. So is this true or false? If it's false, that means there's no solution. So are they consistent or inconsistent? Inconsistent, inconsistent. And no, I was just telling you it is. And what is the solution? The empty set, right? The empty set. On this next one, we might as well do that one too. What are you going to multiply by? -4. -4. So I'm going to get -20x. Yep, that's what's happening in this little set of them. -20x minus 8y equals -48. Oops. And our other equation, 20x plus 8y equals 48. But now what happens? 0 equals 0. And so is that true or false? True. So what does that mean about those equations? They're the same. And true is just for information. And so now, is it consistent or inconsistent? Consistent. And they are dependent. It is true, yeah, right. Oh, just to, but now you know. Okay, and now, so now if the only tricky part on these is if it has an answer, we have to figure out what that answer is. So we want to take either one of those equations and solve for y. Yep. Because these would have all been positive, nothing would have dropped out. Yeah. And because these are actually the same equation. So here, watch. Everything that we did before this. You get an ordered pair answer. You know what's happened when you add these together and like just pretend you get 5x equals 20 and divide and then put that in. That's what it is. So wait a minute, 5x plus 2y equals 12. We have to get y alone. I'm going to subtract 5x and 2y equals -5x plus 12. I'm going to divide by 2. And then can I break this into two fractions? Are you with me on that? That I can break that into two fractions. So I get y equals -5/2 x plus 12 over 2, which is what? 6. And so my solution is the set of all y such that y equals -5/2 x plus 6. And x is an element of the real numbers. And unfortunately, we did not get to graphing today, but we will start with that tomorrow. Wait, say that again. Wait, consistent and dependent, you need it. Oh, the other one you get an XY ordered pair. This is it. No, this is all one problem. That's one of those equations. Oh, ladies and gentlemen, shh. I need everybody's attention. Shh. Okay, I wrote Wednesday here, but it's really going to be Thursday. Yeah, because we didn't get this done today. If you would kindly put the tables back and stack the chairs.